The Earth is warming. We have great confidence that CO2 emissions are what's responsible for man-made climate change, but there's still a lot about climate change that we don't know. Scientists can estimate how hot the Earth was in the past by measuring the amount of CO2 trapped in very old ice cores. But there's still a big problem. Over time, the amount of CO2 in a given region in an ice core can change due to a process called diffusion. This means that the amount of CO2 we measure today in the million-year-old ice core may not literally correspond to the amount of CO2 in the atmosphere a million years ago. For my project, I created a diffusion model that can tell us how much diffusion alters the amount of CO2 in an ice core over the span of 1.5 million years. The diffusion model is a piece of code that uses some fancy math to calculate the amount of CO2 present in an ice core at each time step. There are two factors that can alter how much CO2 diffuses: how fast the ice flows to the surface from underground, and how fast the ice thins. There's another problem though. In the region of Antarctica that I study, we don't know how fast the ice flows to the surface and how fast the ice thins. To get around this, I modeled CO2 diffusion in different possible flow scenarios and thinning scenarios. As a result, this new model gives us an idea of how much we should expect CO2 to change in different possible flow and thinning scenarios. This research is a step forward in interpreting very old CO2 climate data. By knowing how much diffusion can change the amount of CO2 in an ice core, we can have better confidence in what our past climate was like, and even better confidence in what our future climate might be like. Signing off, Shinonso, the physics major in the College of Natural Sciences. Thanks for watching.